Hey, how you doing? Turn down the lights and put those calculators away. It's time for Sinusoids Part 2. We need to recall from our last experience, our first real introduction to sinusoids, that the sine wave is formed by rotating a point around the unit circle. And this, in the same way that a trip around the unit circle takes 2 pi radians to complete, that is the same reason why we see that the period of the sine wave, of the basic sine wave, y equals sine of x, is 2 pi. We need to understand that for any given point along that journey, so for example, I could go to an angle of about 3 pi over 4, like you see on the screen right now. And we need to understand that not only is the angle on that unit circle 3 pi over 4 radians, but we see that the corresponding point on the sine wave itself has an x value of 3 pi over 4. And the y value of both of those corresponding points is equal to the sine of 3 pi over 4, or 1 over root 2, or approximately 0.707. We need to really understand the interconnectedness of all those relationships, and if any part of it didn't make sense, you need to come by and let's clear it up, because even as we go forward, I say especially as we go forward, you really need to understand where that sine wave came from. We also introduced the general form of a sinusoid, and I told you that I preferred this alternate form that you see on the screen right now that really causes us to recall our transformations from earlier in the course. And of course, if there were a negative sign in front of that a value we see there, that represents a reflection across the x-axis, and a negative sign in front of the b value would be a reflection across the y-axis. And I'm hoping everybody's going, yes, I remember all that, that all makes sense. Now in this chapter, we throw out a few new vocabulary words. Amplitude is one of them, and we see that, okay, it's a new vocabulary word, but it's an old concept. It represents our vertical stretch or vertical shrink, depending on the value of A itself. And the only subtle difference is that we make sure that it only has a positive value. We take the absolute value of the A term. And likewise, I have a phase shift here. That's just a fancy word for the H value. We would call it a horizontal translation, but it's also called a phase shift, and we need to recognize that they mean the same thing. Okay, so let's get into our example for today, or one of our 2 examples for today. In your assignment, you're going to be tasked with constructing a sinusoid with a given period, in this case 8 pi over 3, and a given amplitude, in this case 5. And you may even have the extra condition that it needs to go through a certain point, in this case -4, 7. So let's first consider, and this is exactly how I ask that you do it. I'm going to confess there is a formula or 2 in the book that I really would prefer you just ignore right now. So don't go looking for any formulas for this stuff. Let's just think about things that you already know, such as transformations. So if we start with our basic sine wave, we need to recall that when you put an A term in front, that is a vertical translation, and that's a vertical stretch or shrink, and so that's what causes the sine wave to get taller or shorter. So if I were to settle on that, I'd say, okay, that I just vertically stretched it, and therefore I have an A value that is greater than 1. Likewise, if I put a B value in there inside the parentheses right next to the X, I need to recognize that that is going to cause horizontal stretches or shrinks. And when you ask yourself which of those 2 is going to affect the period, that's the first thing we're going to look at here. The fact that we need to have a period of 8 pi over 3, I'm hoping you're recognizing that that's the horizontal stretch or shrink. So I have it color-coded here. This B value is what is going to affect the 8 pi over 3. Now let me just be very clear on something. A common mistake that students make is they say, oh, the period is 8 pi over 3, therefore B equals 8 pi over 3. Not true. B and the period are related, but they are not the same thing. So don't think that we just automatically say B is 8 pi over 3. That is not true. But let's think of what is true and what we already know. Again, as just mentioned a moment ago, and hopefully it's something that you felt comfortable with, the period of the basic sine wave is 2 pi. And when I look at the fact that I want that period to be 8 pi over 3, I'm going to ask, what is 8 pi over 3 in relation to 2 pi? Is it a bigger number or is it a smaller number? Well, it's a little bit bigger. It's a fraction of about 2.66, or it turns out to be a decimal of about 2.666 repeating times pi. So I'm going to put 8 pi over 3 right here and recognize visually that I need to take my basic sinusoid and I need to stretch it out horizontally 8 pi over 3. Okay? Make sure you pause and fully realize how I have determined that I need to horizontally stretch this. Now, of course, the question comes up, how much do I stretch it? So what is the horizontal stretch factor? So I would ask that you approach it this way. The basic period, once again, is 2 pi, but if I horizontally stretch it by some factor that goes inside these parentheses, I want the result to be 8 pi over 3. So again, right here is the horizontal stretch factor that I need, and I need to figure out what that number is. So hopefully in the time that I was writing that, you're thinking, okay, that needs to be a 4 to make, since 2 pi times 4 gives me the numerator, 8 pi, and then I need that denominator of 3. And sure enough, a horizontal stretch factor of 4/3 is what would give me that period of 8 pi over 3. So pause this, let it soak in, replay it if you need to. Make sure you're fully clear on that process, because that's one that often causes students difficulty. All right. How about the fact that I need this to have an amplitude of 5? So the amplitude we need to understand is just the height of the mountains, the depth of the valley. A common mistake is for students to say, oh, is that the difference between, or the distance between the top of the mountain and the bottom of the valley? No. Again, just the height of the mountain from the ground to the height of the top of the mountain, that's an amplitude. And from the ground down to the valley, that's another amplitude. So the total height of the wave is equal to twice the amplitude. All right, so we should know that for our basic function, the default amplitude is 1. We know that the sine wave, and you hopefully in reflecting on the unit circle or thinking about the unit circle, you're clear on why the maximum and minimum values of the sine wave are 1 and -1. And if I want this to have an amplitude of 5, I need this to go, I'm basically needing to vertically stretch that. So this is not to scale. My drawing's certainly not being drawn perfectly to scale, but just the concept I hope I'm making clear, that we need to vertically stretch this. And fortunately, that's an easier case than the period itself. Hopefully, it's evident that the A value will just be 5. And since the amplitude is technically the absolute value of that A value, if I wanted to be cute, I could put a negative sign in there, and that would cause a reflection, and I'd still have the amplitude that I want and the period that I want, but there's no reason to go out of your way to do that. I'm just pointing out that one could do it, and it would still satisfy the problem. So I'm going to clear some of this off the screen and then say this is what we've got so far. We have satisfied the first two parts of the problem. We've got the desired period and the desired amplitude. And the last thing we need to focus on is having this go through the point -4, 7. And the good news is that that one's going to be fairly straightforward to do too. Now, having said that, many students do mess it up, so please listen carefully and make sure you're getting this. But I'm going to take advantage of the fact, first of all, let me just explain there's an infinite, literally an infinite number of ways this could be done. There's an infinite number of possible solutions, but of course we're going to look for the one that's just most straightforward. So let's take advantage of the fact that the sine wave by default goes through the origin. And wouldn't it be the case that if I were to take that sine wave, and move it to the left, that point that was at the origin moves with it, of course, and if I were to move it up, I could move it to the left 4 units and up 7 units, and I would have my, I'd satisfy the conditions of this problem, right? So again, this is not really very well to scale, and this is getting a little bit messy, but I'm almost done here, so hopefully you can hang with me. If I move it to the left 4 units and then up 7 units, I now have a sine wave that maintained its period and its amplitude through that translation, but it now goes through the point -4, 7. So let me just, I'm going to have to clear this up a little bit here, unfortunately, but hopefully, again, you got the idea. If I take my equation and I ask myself, how am I going to move that to the left 4 and up 7? Well, I'm going to get rid of that little parentheses. I'm going to make myself a little room there. And I'm going to say, if I go to the left 4, that's counterintuitive, so I need to do a +4 if I want it to go to the left. And if I want to go up 7, I go up 7. And there's one last thing I need to do before I call it done. And I'm wondering if you can look at that and see what I'm missing there. And hopefully, if you recall your transformations really well, we need to set a parentheses there. If I move something from the left to the left, I need to erase the x and replace it with parentheses x plus 4. So try to recall that subtlety. And if you do, you have a sinusoid that fits the conditions of the problem. If any of that didn't make sense, of course, you know what to do. Come on by. But I'm going to go on to the next example here. I had a student a few years ago who tried this approach on the calculator, and I never got the final word as to whether he was successful, but I wish him well in life. Okay, here's the other part. Specify the period, or the other example. Specify the period and amplitude of the function, then give the viewing window in which the graph is shown. You're going to have something like that in your assignment too. And don't use the calculator to do it. So we're going to take advantage of the same concept here. We're going to say that 4 pi there, that's not the period itself, but it is the, it does affect the period. And when I ask how does it affect the period, I say, well, that's counterintuitive horizontal stretching or shrinking. So if I took the original period of 2 pi, of just a basic cosine wave, that's the period of y equals cosine of x. And if I multiply it by the stretch or shrink factor, that's going to give me my new period. So I'll put the counterintuitive 1 over 4 pi here. And again, given that 4 pi is a number that's greater than 1, then this really counterintuitively represents a shrink of 1 over 4 pi. And when I do the math there, 2 pi over 4 pi gives me just 1/2. So that tells me that the period is equal to 1/2. I turn to my picture here and I say, there is one full period from the bottom of a valley to the next bottom of the valley, and apparently that has a distance of 1/2. Well, I see that I have a second period sitting right next to it. Therefore, this x max value must be just 1. And likewise, on the left-hand side, it's -1. Again, pause and replay that. Think it over. Make sure that you're clear on the process for doing that. We calculated the period first, and then we used that information and counted how many periods there were in the picture to help us determine the x-min and the x-max values. Okay, so let me erase a little bit of that so I have some room here. We'll now look at the amplitude. So the amplitude, again, you're finding is the absolute value of this a term. I can look at the negative sign and then just figure, okay, it'll go away when I take the absolute value. The amplitude is going to be 8. So the amplitude is 8. That is the height of the mountain. That is the depth of the valley. And I notice that if I were careless in looking at this picture, I might assume that the y-min and y-max were 1, 2, 3, 4, 5. I might assume that there's a 5 for my y-max value, but knowing that the amplitude is 8, I hope it's clear that we are counting by 2s. This must be 2, 4, 6, 8. That gives me the correct height of this sinusoid, and therefore the y-max value must be 10. And the y-min value must be -10. So I went through that a little bit quickly, but I hope you hung with me. My x-min and x-max, y-min and y-max values are as such. So I would write on the, as my answer that the window settings, and this is how I'd like to see you do it on a homework or test. I'd like you to see you say that the window goes from -1 to 1. And if you write out x min, x max, y min, y max, I certainly, I don't object to that. But this is the short, acceptable way of doing it too. There are my period, my amplitude, and my window settings. Problem solved. So, your turn. You know what to do. Pause the video, please. All right, and I'll go ahead and show the answers. You should have gotten those answers. If you didn't, and if you can't figure out why, please come see me. If there's any other aspect of this video that was confusing, come on by. Don't let this stuff pile up and snowball into a problem.